Okay, guys, let's now start our unit on factoring. And so last unit, when we were simplifying radicals, you were introduced to this concept of factoring. You probably actually heard of this maybe back in math lab when you were simplifying fractions. But all factoring is the process of rewriting a value as a multiplication problem. Okay, so factoring is the process of writing a value as a multiplication problem. Okay, it's kind of just like a simple definition. The process of rewriting a value as the product of its factors. Okay, and so let's look at this. Let's say if we wanted to factor the number 6, okay, just for an example, how would you do that? So before, when we were talking about factoring, we were doing something very specific where we were trying to factor out perfect squares. I'm not trying to simplify radicals right now, so I don't care about perfect squares. That's not going to be my motivation. My motivation is simply I want to rewrite 6 as a multiplication problem. And there's a way to do that. I can write it as 2 times 3. Okay. Now I also can rewrite it as 1 times 6, right? You can always write a number as a multiplication problem by multiplying it by 1. Um, but we're going to find out there's going to be lots of different reasons why I want to factor. Okay, there's lots of different techniques that factoring will help us solve problems. But when you factor rewriting it like this, um, that necessarily, we won't have a whole lot of use for that right now. Okay, so when we factor, we're going to ignore the factor of 1 times that number. Okay, so when I ask you to factor 6, just ignore 1 times 6. You'll say 2 times 6. Okay, what about 8? How would you factor 8? Well, you could say 2 times 4, right? Or 4 times 2. But there is an idea where you want to factor completely. Okay, and what does that mean? Remember when we were doing fractions and I could do, let's see, 6/12, and I could simplify this by dividing out a 2, right? So 6 divided by 2 is 3, 12 divided by 2 is 6. But this fraction, even though I simplified, I didn't simplify it all the way. I could have actually pulled out another number, which is a 3. Okay, 3 divided by 3 is 1, 6 divided by 3 is 2. So factoring is the same way. Sometimes it's beneficial to us to be able to factor a number all the way. And so what does that mean? Well, if I look at 8 equals 2 times 4, look at the factors. There's a factor of 2 and there's a factor of 4. Is there any way that I could factor those anymore? Like 2, well, the only thing I can turn 2 into is 2 times 1. And I told you we're going to ignore those. But 4 could actually be written as 2 times 2, correct? So if I want to factor this all the way, what I have to do is I take that 4 and I rewrite it as 2 times 2. Okay, so let's take another example. Let's do the number, let's say 20. Okay, how could we write 20? Some of you guys might say 4 times 5 or 2 times 10, right? Either one, we could start with either one. Let's go ahead and do 2 times 10. Okay, now look at both of the factors. I have a factor of 2 and a factor of 10. Is there any way that I can continue to factor either one of those numbers? Well, 2, the only way I can rewrite 2 is 2 times 1, so we won't worry about that. But 10, I can actually rewrite 10 as 2 times 5. Okay, so whenever we're factoring, we want to factor completely. Okay, whenever we're talking about factoring right now, we're going to practice factoring completely. Um, Now, there's some numbers, like let's look at this number 13. How can I rewrite 13 as a multiplication problem? Well, I do know that I can write it 1 times 13, but I said that that's not going to really get us anywhere with our problems that we're working out. So that's not going to help me factor that. Okay, that's not going to help me when I'm talking about factoring. But 13, there's no other numbers that I can write other than 1 times 13. So we have a special name for these types of numbers. They're called prime numbers. Okay, 13 is a prime number. So whenever you cannot write a number as a multiplication problem, other than, 1 times itself, it's the only multiplication problem you could think of, they're called prime numbers, okay? And we're gonna see that here. We're going to talk about now factoring algebraic expressions, okay? So we're gonna factor um, um, statements that have variables and operations and all that. And so we'll always keep in mind two things: that we always want to factor all the way, and that we always want to, and that we're cautious that some values might be prime and that you cannot rewrite it as a multiplication problem. Okay, so now let's take a look at our notes. Now, factoring is taking a number and breaking it apart into two different pieces, right? Two different, into its factors, breaking it apart into a multiplication problem. So what's going to help us here is looking at first, how do we multiply with algebraic expressions? Okay, and we did this last section when we were simplifying. Okay, um, here if we remember the distributive property, right? If we have a times two terms in here, you have to distribute the a to each term. Okay, so if a times 3a is 3a squared. And then I have a times 7 is a positive 7a. Okay, so with this step, all we're doing is showing you how we normally go. We normally have been simplifying, okay? We've normally taken a value that may have been written as a multiplication problem and rewriting it so that it doesn't have parentheses, okay? So what we're going to end up doing today after our warm-up is going the opposite way, taking the simplified form and rewriting it into the factored form. So here you're given the factored form and they want you to rewrite it as a simplified form, okay, in the simplified form. So what do? We distribute, okay? We distribute. So we have negative 2m times m squared is negative 2m cubed minus 12m squared plus 2m. Okay, so once again, I went from my factored form to my simplified form. That's what we've been used to. Again, we can do it with lots of different variables too. 4x squared or 4x cubed y times x squared is 4x to the fifth y minus 8x cubed y squared. Okay, so we can go from this factored form to the simplified form. So today what we're going to be doing and learning how to do is going the opposite way, okay? Taking a simplified form, the simplest form, into the factored form, okay? So maybe we have an example, maybe we use this example. What are they going to do? They're going to give you this, and it's going to be now your job to be able to rewrite it like this, okay? Do you notice how you're rewriting it into a multiplication problem? This is a times all of that, okay? So you are factoring, okay? We call it a factored form. So just remember that what we had talked about, polynomials that can't be factored, just the same as numbers that can't be factored, we call them prime, okay? So For the next couple weeks, we're going to be exploring lots of different techniques to being able to factor, okay? So multiplying was fairly simple, straightforward, okay? You were putting one thing into the other. Factoring sometimes can feel a little bit more difficult, okay? Because, um, sometimes there's several terms going on, things being multiplied. And so we're going to have lots of different techniques. So every day for the next 4 or 5 days, we're going to be looking at several different techniques to being able to factor. So today we're going to go over our first technique, and that is referred to as factoring a greatest common factor. Okay, a greatest common factor. So here's my steps. First, what I need to do is identify the greatest common factor. So identify what can you factor out, okay? What can you factor out? So whenever you're doing that, since an algebraic expression is made up of numbers and variables, you need to check them separately. So first check the coefficients and then check the variables, okay? Now, when you're looking for the coefficient, you're asking yourself, what number can divide evenly into both of my values, okay? So like on number 1, I look at my numbers. I have my two terms are 3x plus 12. So I look at the numbers first. I have a 3 and I have a 12. Is there anything I can divide evenly into both 3 and 12? Yes, I can divide a 3 out of both 3 and 12. Okay, so when I do that, all right, this is me checking the coefficients. I'm gonna tell you there's no variables right here. There's no factoring of the variables, so we'll come back to this one. But all I need to do in step 2 now, since I identified the greatest common factor, which is a 3, I needed to divide each term by that greatest common factor. So I set up my division, 3 divided by 3, 12 divided by 3. And what we need to do is leave the remaining factors in the parentheses. So since I can divide a 3 into both, I'm gonna pull it out. Okay, I'm gonna pull out that 3. And I'm gonna leave whatever's left inside of my parentheses. Well, here, 3x divided by 3 is just x. Plus 12 divided by 3 is just 4. Okay? And that's it. Okay? All I'm doing is I'm pulling out a common factor, something that I can divide evenly into both terms. Now, if you'd like, step 3 says check your work by distributing. If you're not sure that you're doing this right, go the opposite way. You know how to distribute. What would that look like? 3x times 3 times 4, so 3x plus 12. Is that what you started with? Yeah, 3x plus 12. I know that I factored this problem right because when I distributed, I got what I had started with. Okay, I had the value that I started with. So let's do another one. I'm going to ignore this part again because we don't need to do that yet, but we'll see that here in some of our next ones. So let's look at the numbers. I have 7y and -7. What can I factor out of both terms? So I look at the numbers 7 and 7. What can I divide evenly into both 7 and 7? Well, I can divide a 7 out, right? All right, there's no variables. I'm going to kind of give you that hint. But so what I need to do is pull this 7 out. So I pull it out. Okay, I'll just my common factor is 7. All right, so I pull it out and then I divide each term by that 7. And what do I have left over? Well, 7y divided by 7 is y, minus 7 divided by 7 is 1. So my factored form is 7 times the quantity y minus 1. Okay, so what we're doing is we're going backwards. Okay, we're solving this. Instead of simplifying, we're rewriting it as a factored form. All right, so number 3, let's start looking ones with have variables, but these won't be too difficult. So I'm looking at the numbers first. I have 8 and 36. So what can I divide into both 8 and 36? Well, I think I can divide a 4 out of there. Okay, 8 divided by 4 is 2, 36 divided by 4 is 9. So then you look at your variables. What you're doing is you're looking for a variable that is present in all of the terms, okay? So it has to be the same variable. So here I have an m and I have an n. They don't have those in common, okay? Those are different variables. So with these two terms, they don't have any variables in their common factors. So I won't have anything to do with the variable. So 4 is the greatest common factor, so I'm going to pull it out. And what am I going to be left with? Well, 8m divided by 4 leaves me 2m plus 36n divided by 4 leaves me 9n. Okay, so 4 times the quantity 2m plus 9m, that's going to be my answer. Okay, I'm going to leave number 4 for you guys to do. All right, so sometimes we'll have lots of variables going on. Okay, so I have 6a squared plus 27. So I always look at the coefficients first. I have 6 and 27. Is there anything I can divide evenly into both? Well, I know I can divide a 3 into both 6 and 27, right? And I look at my variables. This one has an a squared. That doesn't have any variables, so there won't be any common variables. So I'm going to be left with, I'm going to pull my 3 out. And what am I going to be left with? 6 divided by 3 is 2a squared. And then 27 divided by 3 is 9. Okay? So this is completely factored. If you want to check to make sure you're doing it right, go the opposite way. Distribute. See if you get what you started with. Okay. Now look at some that we might see a common variable. So I'm looking at first my coefficients, 4 and 24. What can I divide out of 4 and 24? Well, I'm pretty sure I can divide a 4 out, right? 4 divided by 4 is 1, 24 divided by 4 is 6. Now let's look at my variables. This guy has 2 factors of y. This guy also has a factor of y. He has 1 factor of y. So if I'm looking at which ones do they have in common, how many do they have in common? Well, this guy has 2 factors and this guy has 1. So they only have at most what the smaller guy has. So there's a common factor of y. Okay, they each can give a single y. All right, so what are you going to be left with? So I'm going to pull out the 4y. And what's going to be left? 4y squared divided by 4y leaves me just y, minus 24 divided by 4 leaves me with 6, and y divided by y cancels out. So I am factored. I have 4y times the quantity y minus 6. Okay, let's do another one. Let's say we've got the 21 CD divided by negative 3d. So what can I divide out of each term? Okay, I can divide a 3, right? 21 divided by 3 is 7, and 3 divided by 3 is 1. I also see that I have a common variable as well. They both have a d. They both have 1d, so I can take that d out. So I write my greatest common factor. My greatest common factor is 3d. And what do I have left? Well, 21 divided by 3 is 7. CD divided by D is just C, right? Because the D's go away. Minus 3 divided by 3 is 1, and D divided by D is 1. So just minus 1. And that's your answer. Okay, I'm going to leave number 8 for you. Now let's look at number 9. So I'm looking at both of my terms separately. I'm going to look at the coefficients 15 and 30, right? I know I could divide a 5 into both or a 3 into both, but I also can divide a 15. So what I'm trying to do is divide out the greatest common factor, okay? Greatest. All right, so my first term has 2 factors of A, and my second one has 1 factor of A. So they have in common 1 factor of A. They can both give me an A. Now, do they have B's in common? Yeah, they both have 1 factor of B in common. So if you notice, I can't say they have a common factor of A squared, right? Because the second one doesn't have 2 A's to give, okay? So you can only take out what the smallest amount of factors have to give, okay? So I'm gonna pull out my 15AB, all right? And now write what I have remaining. Well, 15 divided by 15 is 1. A squared divided by A is A, and B divided by B will go away. Minus 30 divided by 15 is 2. A divided by A is 1. B divided by B is 1. So I'm just left with A minus 2 inside of there. So this is my factored form. Okay, I'm going to leave number 10 for you. Let's look at number 11. So I'm looking at each term. I don't have any coefficients other than the number 1. So I won't have any constant values that I'm going to pull out. But I do see on my variables that they both have an A, right? They both have an A to give. So that's what I'm going to do. I'm going to pull out the A. And what am I left with? Well, A divided by A is 1. And I'll be left with a B. 1 times B is B. And then A divided by A is 1 again. So my quantity is A times B minus 1. Okay, I am going to leave number 12 for you guys. 13, let's look at the numbers 5 and 13. Is there anything I can divide evenly into 5 and 13? No, there's not. And do they have any common variables? No, this has an X and this has a Y. There's nothing that I can factor out of both of those. So this value is prime. Okay, so now let's look at 14. So I have 18a squared bc squared minus 48abc cubed. So I look at the coefficients first, okay, and I'm looking at 18 and 48. Well, I know I can pull out a 6 from 18, okay, and then also I can pull out a 6 from 48. So I know I have a common factor of at least 6. Now let's look here. This has 2 factors of A, and this only has 1 factor of A. So the only thing I can pull out is 1 factor of A. They have that in common. Here they have they both have 1 factor of B, so I can pull the 1B out, okay, the 1 factor of B. This one has 2 factors of C, and this one has 3 factors of C. So I can pull out at most 2 factors of C. They have those 2 factors in common, so that's what I can pull out. So I'm going to go ahead and pull this out, 6abc squared. And now all I'm left to do is simplify these rational expressions, okay? So if we remember, let's go ahead and go 18 divided by 6 is 3. A squared divided by A is just A, right? You subtract those coefficients when you're dividing. B divided by B goes away. C divided by C goes away. Minus 48 divided by 6 is 8. A divided by A goes away. B divided by B goes away. C squared divided by C, or C cubed divided by C squared is just C. So that is my factor form. Okay. So we can do this with several terms, okay? It doesn't just have to be 2 terms. Number 15, I see that I have 3 different terms here. So I have to look at one that they all 3 have in common. Well, look at the coefficients, 2, 2, and 4. I can pull out a 2 from each one of those terms. Okay, now let's look at the x's. This one has two factors of x. This one has 1 factor of x, and this one has 1 factor of x. So how many can they all give? Well, they each could give 1 factor of x. So that's what I'm going to use. And then y, once again, I see that at most they can all give one factor of y. So I'm going to pull out 2xy, and what am I going to be left with? I'm going to be left with an x in that first term minus y plus 2. Okay? So I'm going to, whatever's left inside, whatever's going to be left is what I write inside the parentheses. All right, just erase that. So on 16, let's look at those. So what can I divide evenly into all three of these terms? Well, I know I could divide a 9 into 9 and 18, but I can't divide a 9 into 24. So that's not a common factor of all three terms. I do see that I can divide a 3 into all three of those terms though, right? 9 divided by 3 is 9, or is 3, 18 divided by 3 is 6, and 24 divided by 3 is 8. Okay, I also can pull out some R's. I see they all have at least one R. So I have 8 R's here, I have 2 R's there, and 1 R there. So at most, I can pull out that 1 R. They all can give 1 R, all right? You couldn't pull out any more, right? Because the idea is that if you can't take, let's say you were like, oh, well, maybe I can pull out 2 R's because but this guy doesn't have 2 R's to give. So we want it, that's not what they have in common. All right, we have to see what they all can give the same of. And then S's, the first guy doesn't have an S at all, so I can't even, so there will not be any S's in my factor. Okay, so what do I have left? Well, 9 divided by 3 is 3. R to the 8th divided by R is R to the 7th. Minus 18 divided by 3 is 6. R squared divided by R is R, and then left with an S. Minus 24 divided by 3 is 8. R divided by R goes away, and you're left with S squared there. Okay, and like I said, you can always check these by factoring, okay? By factoring. So 17, what can I divide into all of those? Well, 2, 14, and 10. I think 2 is going to be the biggest number that I can pull out. And then looking at all the factors of y, they can all give 2 factors of y. Okay, I see that they all can give, that's a common, that's what they have in common, is 2 factors of y. So I have 2y squared, and what will I be left with? 6y to the 4th divided by 2y is 3y squared, plus 7y minus 5. Okay, I'm going to leave number 18 for you guys. And let's see, we'll leave number 18 and 19 for you. All right, so let's do number 20. So what can I divide into all three of these terms? Well, I know I can divide a 9 into 18 and 36, but that's not going to work for 24. I know I can divide a 3 into all of them, or a 2, or a 6. So I'm going to pick the 6 because that's the greatest common factor. Okay, so I'm looking at the x's first. This guy doesn't have any terms of x's. So even though the first ones have x's to give, since that last one doesn't have any to give, that's not what they have in common. So I don't have any factors of x. I noticed that 2 of these have factors of y, but the middle one does not. So they don't have any y's in common. Now z's, they all have z's. The first one has 1 factor of z, and the next have more than 1. So that means they can all at least give 1 factor of z. Okay, so 6z will be my common factor. And what will I be left with? 3x squared y minus 4xz plus 6yz squared. Okay, and as these are getting bigger, maybe you want to distribute to make sure that you're doing these correctly. All right. Okay, so wrapping this up, what can I pull out of these guys? So I know they all have they don't have any common coefficients. So let's look at the variables. I got 1 factor of n, right? Because this only has 1. So that's the maximum that they all can give. And then I also have 1 factor of n. Okay, I have 1 factor of n. So What am I left with? I'm going to pull that mn out, and I'm going to be left with m squared minus mn, right? You subtract those coefficients, plus 5n squared. Okay? All right. And I am going to leave the rest of these for you guys to do. Okay? So if you guys have any questions, come see me on Zoom today.